So continuing on, we are now doing question number 6, which involves complex numbers, squaring a complex number. General terms, if you write the standard form for a complex number and you do z equals a plus bi, and I want to square it, square just means I would write it twice and I would FOIL. All right, so I'm just going to write the word FOIL here and give it a dot, dot, dot. I'm assuming you're all familiar with this word. First, a times a, outers, a times bi, inners, bi times a, which is also a times bi. Last times last, bi times bi is b squared, I squared is equal to -1. We would just FOIL if we had nice, easy numbers. We have cosine of 60 degrees and 2's and whatever. These numbers that I actually gave, because I changed the ones from your book, these numbers actually work out nicely. If I got these values by doing SOHCAHTOA and got the lengths of the sides of these things, the 2 cosine 60, this is just 1/2 times 2. My z ends up being this. It'd be pretty easy to make this a 1 plus a rad 3i, 1 plus rad 3i, and do that. The question in your book doesn't have 60 degrees, it's got 10 degrees, and that does not give you a special triangle. So the one in your book, we have kind of no choice but to leave the cosine 60 and sine, or cosine 10 and sine 10, they gave you a 10-degree angle. We have no choice but to just leave a kind of a funky angle in there and to go through it with the trig functions. That's why I have these 2 blue ones written over here. We're going to run into these later on. They're going to occur in this question. I also wrote down Euler's or de Moivre's. De Moivre's theorem tells you how to do this stuff really, really easily. If you're taking a complex number and raising it to a power or doing a root, it tells you how to do that. So if you want to get online and look up Euler's theorems and de Moivre's theorems for complex numbers, it'd save us a lot of time in doing this. We're not going to do them here because it's not really in your course. So for the z squared, I would want to write this thing down twice and multiply. I'm going to drop it down a little bit and maybe write it a little bit smaller just so I can have room on the board. I'm going to drop my degree circle. We are in degree mode. In general terms, when you do circular stuff, you want to go to radians. This will work just fine in degrees. So I'm going to keep it here because I don't want to carry around pi over 3 and pi over 3. It gets kind of cumbersome. So if we do this, first times first, these 2, 2 times 2 is 4, cosine 60 gives us a cosine squared 60. So this is going to be a 4 cosine squared 60. When I do one of these, I'm going to real quickly write this down again, refresh your memory in case you've forgotten how to square a complex number. What happens if you do one of these? Right, whether it's an I or if it's a variable, I is not a variable, I is a constant value. I'm going to make it an X, doesn't matter. I could just make it a B. If we do this, they're just B's now. Binomial FOILed with itself squared, right? If I do this, first times first gives me an A squared. Outers give me an A times a B. Inners also give me an A times a B. They're written backwards, B times A, but we have a commutative property for multiplication, so I can swap those around and make it an AB. Last times last gives me this. So if I'm FOILing, it really comes in handy to learn how to FOIL a binomial, how to square a binomial, I should say. How to square a binomial, you get the first and last squared. So if I'm just doing this, I'm going to have that squared and that squared, 2 times that product. And it comes in handy to know it. That's what we're going to have up here in this one. Right? So it comes in handy to not have to write it twice and do that. If you're squaring a binomial, I'd recommend that you learn how to do it without writing it twice. But if you have to write it twice, know your limitations. If you got to write it twice in FOIL, go for it. Outers are these. Right, 2 times 2 is 4. We've got an I, we've got a sine 60 and a cosine 60. I'm going to write the sine first just so it looks like that. Right? So we'd have 2 times 2 is the 4. I'm going to pull the I out to the end. Inners, I also have a 2 times 2, which is 4. I've also got the I. I've got a sine 60 and a cosine 60, so we're going to get 4 more of these. Same exact thing, which means they are like terms, which means I should be able to add them together. If I add the 4 of them plus the 4 of them, it gives us 8 of them. I'm just going to make that an 8 to save the board space. So make sure you can do the algebra on that. So that becomes an 8 because I have to, outers give me 4 of them, inners give me 4 of them. That's the 2ab from a plus b squared that I just wrote down here. I'm just going to make that an 8. So we have that. Last times last, these two, positive times a positive, so plus 2 times 2 is 4, I times I is I squared. I'm going to write it on the end. Sine 60 times sine 60 is sine squared 60. Here's our times I squared. So we are getting closer to be able to use these blue things, right? In general, I may not be going into this question knowing I've got to use that blue stuff in the upper right corner because nobody's going to give me an upper right corner and tell me I'm going to need that stuff. So in general, I'm just going to be looking at this and going, what can I do? One of the first things I would do is to look at that I squared, because we don't want to leave an I squared on the board, right? When you get i's raised to powers, you always want to go through this routine of I to the first just equals I to the second, right? I by definition is the square root of -1. If I square both of these, I squared becomes just -1. I to the third is I squared times I. That's -1 times I, so we get a negative I. I to the fourth would just be I squared squared. -1 squared is just +1. So you get these 4 things just repeat themselves. Positive I, -1, negative I, +1. So you get plus or minus I plus or minus 1 out of I raised to any power, right? So you kind of want to keep those things in mind. Don't give an answer like this. This, if I divide by 4, I have a remainder of 3. That's equal to I to the third. So I'd replace it with negative I because that's what I to the third is. So don't leave I to a power laying around. So general terms, I'm going to look at that and go, I don't like it. Don't like an I squared. It's going to become a -1. So since I squared is -1, that's going to become a -1. So I'm just going to do it up here, save us the time and the space. That's a -1. That will change that to a minus sign. So I'm going to do that up here as well. I'm just going to make that a minus sign, so make sure you can all see this. Plus that term's got a negative for a factor, so we're just going to combine it over here and make it a minus sign right here. So I am skipping steps on this, combining steps. Don't let your students do too much of that. They will make mistakes with their notation and they'll blow the notation. My algebra is probably a little better than theirs. You know, call them out on their notational things. If they combine 5 steps in one line, they're probably going to blow it. These things here, we're going to pull these together so I can start looking towards, oh man, how can I simplify a cosine squared minus a sine squared? Hopefully that one will pop into your brain and you'll say, I can pull them together, cosine of 2 theta. I'm going to rewrite it with the 4's there pulled together, or with the cosine squared minus sine squared pulled together. This, I'm going to rewrite that 8 as a 4 times a 2. So it can match up to that up here. 2 sine theta, cosine theta, well there it is. Times the 4 because it was 8 of them. I'm actually doing this question for the 2nd time in a row because I dropped one of those 2's out of existence and got down here and had a 4 and a 2 and I'm like, just felt something being wrong and figured I might as well erase it and do it a 2nd time through rather than trying to make the corrections on the board because I will blow it too, just like your students will. So this thing here, I'm not quite ready yet because we don't have any 4's on this side. So there are a couple of options. One, if I wanted to, I could multiply both sides of this by 4 right? So I could just say, let's multiply both sides of that equal sign by 4, and I could rewrite my formula as 4 cosine 2 theta equals 4 cosine squared theta. Nobody ever does it this way. But it could. It'd be valid. I could do that, and then I could say, well, that stuff there exactly matches 4 times cosine of 2 theta. It'd be valid. You know, as long as you don't blow the algebra somewhere, you can always rearrange your formulas. So I could use that, but instead I'm going to factor the 4 out because most people are probably going to use this here. So instead of doing what I just did up there, I'm going to factor this 4 out of both terms. If I do that, I'll leave a blank space. It would look like this. This 4 just stays a 4. The cosine squared minus sine squared theta, that exactly matches that, with theta being 60 degrees. So this stuff will become cosine 2 theta, with the theta being this 60 degrees, which is a cosine of 120 degrees. So you'll notice we just took an angle of 60 degrees that we started with and doubled it. We doubled it because of the second power. And that, if you look up de Moivre's theorem, you'll see that taking place in the theorem. So this just becomes I'm going to go ahead and leave that there while I write the rest of it. This over here. By that top one there, go ahead and get rid of this 4 times it. By that top one there becomes a sine of 2 theta, or sine of 2 times 60. That's a sine of 120 degrees on that. The 4 stays out of it because there's no 4 on this one. So we still have that 4, it's right there. Sine of 120 degrees. I dropped my I out of this one, my apologies. We had it because it was right there. So now I'm going to go ahead and erase this stuff that I'd use kind of to explain with a couple more steps rather than combining too many of them. We have this. Here's an A. There's a B. And this is just an A plus BI, just looks kind of ugly. But it's A plus BI, so we have it in standard form. If we did it, I believe they want you to, yeah, they want us to draw a graph for it. So if we draw a graph, I'm going to go ahead and draw them down here. We started off with one where if I did x-axis, this is where we put our real numbers. The y-axis is where we put our imaginary coefficients. Right? Our real is going to be 4 cosine of 120, right? And if I look at things, and I remember this stuff, if that r is a 4, then our standard trig angle of 120 would give us that. That 4 sine of 120, that matches this perfectly. So this is our A. That's our B. We can kind of read them off of this. We're going to have a hypotenuse that's 4 units long at an angle of 120 degrees. We started off up here. X equals r cosine theta. Y is, ignore the I for a second. Your y is the r of 2 times the sine of theta. Without the I, that exactly matches that one here. So we started off with a 60-degree angle and a 2-unit long length. So initially, We started off 2 units with 60 degrees. If we're doing this as a right triangle, that's a 1, that's a rad 3, because again, I did it up early. Might have been on the previous one I did where I, right before this, before having to start over again. If I did my 2 cosine 60, I would get this 1 unit. We started off right here. That point in the complex plane, that represents 2 cosine of 60 degrees plus 2i sine 60 degrees. When you square it, that guy's named Demoivre's theorem. We're going to square the length. It's going to become 4 units long. We have a 4. We're going to double the angle. So we're going to end up with 120 degrees. We come over here. Double the angle because of those trig things. So it would have been easier to do that stuff, but again, not covered in the course, and we get that stuff up here. So there's 4 cosine 120. Did they want this in polar form? They wanted us to match a graph. They couldn't give us a special angle of 60 degrees because if they did, we'd end up going to a different quadrant. And we don't really have any scale on these XY axes on their questions. They didn't put down slashes for 1, 2, 3, 4, whatever. So we really can't tell what that angle is. That angle looks to be about 20 degrees roughly, because it will be. Looks to be about 20 degrees. All we know is that anything from 0 degrees to 90 degrees is in quadrant 1. We're going to get a 20 degree angle, so as long as there's only one of those arrows that's in quadrant 1, we'd be safe choosing it. Their answer choice in your book is D. It's the only possible one that's correct. Not having any like 1, 2, 3 kind of scale written down on their stuff means we can't really tell what that angle really is. But if we got past 45 degrees, we'd be doing a second quadrant sort of thing when we squared it. So they had to give you a smaller angle. They could have given you a 30 degree angle and it would have ended up at a 60 degrees, so they had options. But they chose not to give you a special triangle. Anyway, if we graph this, 4 cosine 120, if we're doing 120 degrees, it means this is a 30 degree one there. Our reference angle is 60 this way if we wanted, but this is what we have for our end result, right? So we'd be finding one of those. Theirs, if I just change these 60s into 10s, these would now be 20. So we kind of using a little deductive reasoning. I can't call it inductive because we didn't prove anything math-wise. But we might be thinking that we'd end up with this. A 20 degree angle. If these had started off as 10 and they got doubled because they did, because of the 2's up there, if we took that 10 degrees in your book and doubled them, we'd probably end up with that. The one they gave you, they didn't have a 2 out front. Their radius was just 1 unit, and if we square 1, we get 1. So we might be thinking we'd end up with one of these that's got an R of 1 and a theta of 20 degrees. And that's what we'd end up with if we actually used the numbers they gave in your book for this question. For this in here, though, again, if you go through that same step, all those same steps, if these are 10 degree angles and those are 1s, then that's a 1 and these are still 10s. That's a 2 and these angles are still 10. If these are both 1s out front, then we don't have this 4 here, we just have a 1. These would have become 20 degrees. So you can walk through it, hopefully, and arrive at the only answer choice you'd have, which would be answer choice D. The important part for doing that question, I don't know why I'm erasing it so quickly. The important part for doing that question is that if I take, I'm just going to make up some number, I'll just call this R. If I do one of these and I want to raise this to a power, we're doing it real fast. It's going to do this for you. 5th power. So to cut to the chase, it's going to have an I in it. It's going to multiply your angle by 5 if you raise it to the 5th. If that's a squared, it's going to double your angle. That's kind of what you need to keep in mind. So anyway, that was number 6.